Okay, so VCF Midwest was fantastic for a number of reasons. Had a blast. But one thing that happened more than a few times, actually many times, at my table display of Atari STs, I had a lot of people asking, well, are any of these for sale? Are you selling anything? And I said, yes and no. I don't have anything here that's for sale, but I have a whole load of Atari STs I'm refurbishing right now. So a number of individuals have reached out already to me from VCF as well as from other sources. And so what we have here is this is the first of the refurbishments. This is a pretty common set of refurbishment requirements. Number one, first off, we need to replace the PSU. I could recap this PSU that's here, but I actually prefer to replace it. What I'll do is just remove what we have here and wire in this Meanwell. It's an RD35A. The D stands for voltage 1 and voltage 2, two voltages, double voltage, whatever you want to call it. And in this, I think the A stands for what types of voltages those are. And in this case, it's plus 12 and plus 5 volts, which is exactly what a 1040 ST needs, or an STF needs, which is different than some of the other Atari STs. But for this one, and the majority of Atari STs, an RD35 is fantastic. 35 is the 35 watt output, perfectly capable. I think the original ST outputs, I think it's in the order of 30 or 32, something like that. I'd have to double check. It's in the ballpark of 35 watts. So step number one, get power. Step number two, what you see here is no floppy. Well, so this has the big button floppy style. And big button floppy style, it's actually kind of hard to find those that are working. The smaller button floppy styles are easier to find and are typically more robust. The path we're going to go here, which will actually make it more useful to most people, is install a Gotek. So here is a naked Gotek outside of its case. What I need to do with this is I'm going to flash the firmware on it with flash floppy. We'll have to do a little bit of soldering here to enable flashing, blah, 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 blah. Get that put in place. We'll mount it on a mounting bracket. We have a black mounting bracket here and a kind of a beige. I've tried matching colors with the Atari STs, just given how they yellow, and it's hard to match. Whatever color I pick, it ends up not matching. So I usually like to go with like a black, just because it's neutral in color and will match most anything decently. But I have both. We'll take a look at both, how they work. In addition, with the Gotek, we're going to install a rotary selector. I like this because it's a lot easier to work with than these buttons. We'll have an OLED that will replace the simple numeric. So when you actually boot up the Gotek, it'll actually have a readout of exactly what the image name is and such. Super cool. And then lastly, the first individual who wants an Atari ST, he wants his Gotek to sound like a floppy drive. So we have a piezo speaker. We'll install this guy as well. Fantastic. Additionally, as you can read here or see on the board, is we're missing the number 2 key. The nice thing about working on a lot of STs, I have some spare parts. And in this case, I have a number 2 key. It's perfectly valid, perfectly usable. It may not match the color exactly, but it'll be good enough. And I can 3D print a stem here as well. That'll work fine. That is what we got going on here. I am not going to retro bright it. I will leave the coloration up to the new owner. Actually, one more thing. This has TOS 1.0 on it. And I'd like to try to, at least when I refurbish these, I'd like to try to give most people a TOS 1.04. That gives folks the most flexibility in what they run. If someone wants to just run a Gotek, and that's all they'll ever do, and they'll only run games, et cetera, et cetera, et cetera. They're never going to consider running a hard drive. TOS 1.0 works fine. It works great for that. And it'll save those individuals some money because otherwise I have to buy the ROM chips. And in this case, I've got 6 ROMs here, six EPROMs that I will burn TOS 1.04 onto, and I'll go through a bit of the process associated with that. And most importantly, we have the Atari coaster from VCF Midwest, on which I will place beverages, and also I will place beverages on the Ultima 4 coaster. And when everything is done, we will be testing Ultima 4 on this Atari ST, and we will test it from the Gotek. Let's get to the first steps. Okay, so I'm going to use my Mega STE right here, this guy here, and to demonstrate the ROM splitter tool. This is necessary to take a ROM image that you might find on some website online and convert it into the high and low, as well as the various different components. Take it from a .img file to the high 1, high 0, high 1, high 2, low 0, low 1, low 2 from a TOS 1.04. And similarly for like TOS 2.06, emuTOS, etc., into the various different components for an Atari STE, an Atari STF, and Falcon, Atari TT, and so forth, right? So this is a way to split up the ROMs. Actually, in a Falcon, it's just one chip, so you don't need to worry about it. But I have it on this floppy disk, copied from my PC. And we will open it up. And we have a TOS image. I'm just going to copy to the hard drive. And the ROM split program. We're going to copy it into storage because I want to copy to storage. Oh, did I already have it there? Maybe I already have it. Ah, I already have it there. Love it. I already had it on this computer. Look at there. So, look what I'd done. As I'd actually split up emuTOS. Very good. So let's do actually TOS 1.04. I'd split emuTOS into a high and a low to use in an Atari STE. We'll perform the same function on a TOS 1.04 image. This is the US image in this case. So ROM split 2. We'll load the image file, actually we'll into 6 parts. Load the image file, ROM split, TOS 1.04.us. Okay. And we're in 6 parts. Split. And we're done. It's as simple as that. And so what we have now, high 0, high 1, high 2, low, actually that's the base, low 0, low 1, low 2. Bada bing, bada bang, ready to burn. Here's my programmer. And we'll take this IC, plug it in here, and we hit the program on the software, and bada bing, bada bang. All right, after you put the EPROM in your programmer, the first thing you're going to do is you're going to want to select it, search for the device in the library of the various different EPROMs that you can burn. In the case of a 520 ST, 1040 STF, etc., for the 6-chip ROM installation, you want to have a 27C256. There's a lot of different types. There's Hitachi, there's ST, there's I think even AMD, different versions of manufacturers that manufacture these types of EPROMs. But you want a 27C256. You can use a 27C512. You just have to do some finagling with the ROM image in order to make those work. All right, I'm going through a couple different things. I turn off check ID and pin detect. For some reason, my programmer doesn't like these chips. It could be they're not exactly legit, but they work, right, in these cases. So I just turn off check ID and pin detect, bada bing, bada bang. I then load up the image. So as you can see, I've got a bunch of different images here. I'm going to load up specifically, I think, yeah, this is TOS 1.04, US high 1 or high 0. This is high 1 in this case. All right, click OK. And then you click up on the program and it programs it. It writes that portion of the ROM image to this EPROM. And you repeat it 6 times in this case, and you're good to go. Now, I know those of you who are doing this or want to try to do this for the first time, you will never make mistakes. However, me on my side, I make mistakes. I will occasionally write high 0 on 2 different chips and just make a mistake, or low 2 on multiple chips, etc. And what do you do in those cases? Well, you need to erase the EPROMs. I use a UV phone cleaner to do this. It works fine. It does the job. It makes it work. You can get a dedicated EPROM eraser that doses these things with a high amount of UV light and erases them relatively quickly. In my case, the phone sanitizer, phone cleaner that uses UV light, it takes about 10 minutes, 10-15 minutes in order to erase an EPROM. It works. Now that the software is done programming, I simply I'm very simple. I do not make fancy labels. I use masking tape. I cover up the window, the UV window. I pop the chip out, and we'll just show you how I just record what it is. This is my way of doing it. 1.04. And this is high 1. There we go. Fast forward just about 10-15 minutes, that max, and we have high 0, high 1, high 2, low 0, low 1, low 2. This is TOS 1.04. That fits perfectly in a 6 ROM chip Atari ST, which any of the STFs, STs, virtually all of them will accept this. You may have to make a little switch and you may even have to add some sockets on some Atari STs, but this will work in all of them. It will not work in Atari STs. All right, we're going to pull off the PSU and expose our lovely ROM chips there. We have 6 ROMs for the TOS, and we'll just replace them with the new ones. Now, one of the essential bits with this is knowing which ROMs are which. You can look up each of the individual part numbers here, and you can usually find it online, Google it. You can also look at the revision of the motherboard. There are a lot of different revisions of Atari ST motherboards. I don't know, 4 or 5 at least. And the ROM chips and the locations are different in each. So it makes sense to make certain that you know where those are. In this case, on this motherboard, as I've looked at it, I believe low 0, low 1, low 2, high 0, high 1, high 2. Now, it's not going to damage the computer if you put the ROMs in incorrectly, but the computer will not work. So let's get working on it. We'll just do the nice little twist method. Lift it up a little. Notice I am not digging into the motherboard. I'm just using twist methodology to get this off and staying near the legs. If I need to leverage, I leverage on the socket, not on the motherboard. And then the last ones, just twist them off. Boom, done. First row done. Now let's remove the back. All right, getting just a little thicker screwdriver now. There we go. All right, and we look at where the notches are. Notches are towards the back of the case, or actually, notches are toward the back of the case. Now, one thing that's interesting, let's look at these sockets. The sockets are incorrectly placed. You see the notches here? If you look at the silkscreen, the notches are towards the back. In general, when I'm looking at these Atari ST boards and the ROM sockets, they tend to all go in the same direction. So I'm not going to follow the directions of the socket, but more the directions of the silkscreen. So we have low 0 here, and we will place low 0 in here. And just make sure that there are no legs that got bent or popped out. That is a common issue that I have. Again, we got the notch on the top. So my storage is full. I'm not sure how far I got with this, but hopefully you saw me inserting these low 0, low 1, low 2. And the one thing I mentioned earlier is that these top sockets appeared to be installed incorrectly, at least initially. The silk screen shows the notch to the top. The socket shows the notch down towards the bottom. I went with the top, what the silk screen said, and then let's test it out. Putting back in the test power supply. Let's get this guy back in here. Plug it in. And what I'm going to do is I'm just going to use the diagnostic cartridge, because that'll tell me right away what TOS is running on this guy. And you can see there, oops, there we go. Version 1.4, looking good. Everything's looking good the way I want it to be. So we have one thing down, two things down, kind of, and a few more to go. While I have the diagnostic ROM up, well, I might as well test the keyboard. See if I need to do anything. Well, the K key works at least. Well, that is a perfectly functional keyboard, albeit a little dirty, so we're good to go. Obviously, I still need to swap out the stem and put the keycap back on, but that shouldn't be too big of a deal. Okay, so working on the keyboard here. This keyboard is really dirty. Pulled out the keys, put them in a nice little container so that I can get them all scrubbed up. Next thing I'm going to do with this keyboard is I'm actually going to remove the back plate, the PCB, pull out the rubber domes as well as those keyboard key stems, replace the broken key stem, and get this thing clean. Okay, I've removed the back PCB, and as you can see, we got the stems that I'll put aside as well as the rubber domes. While I have the PCB off, this is an opportunity. If you look in the upper right hand corner, that's where the joystick and mouse ports are connected. There are oftentimes some dry solder joints there, and so I'm going to reflow those just briefly, add a little flux to it, reflow the solder there, maybe add a little more solder as well. But we're going to get this all tip-top shape and good to go. So I'm not going to be filming the cleaning of the various different parts of the case, etc., etc. But what you see here, this is a 3D printing of a new stem to replace the broken stem on the keyboard. There is a great model on Thingiverse that you can download, and as you can see, it printed out pretty nicely. Here is a side-by-side comparison of the broken original versus the 3D printed version. I cleaned it up a little bit before I stuck it in there, but it works flawlessly. While I didn't film the cleaning, what you can see is the after effects of that cleaning here with the top plate of the keyboard. It is looking great, cleaned up really nicely. I have also in the top of this image here, you can see all of the keycaps that have been scrubbed and cleaned. I did not retrobrite them, so you see some discoloration still, but that is not dirt. We're in the process of reassembling with loads and loads of little tiny screws, domes, and keyboard stems. After the tediousness of putting in the stems, domes, and then screwing back in the PCB, we have this as such. Again, if you saw the before and after picture, this is a heck of a lot cleaner. There is still that discoloration, but it looks a heck of a lot better. You can see the F9 key is the one that has the replacement keyboard stem. All right, the reason I show this here is just to show on the Atari STs, I like to put in these three keys first. The left large shift, the space bar, and the enter key. Largely because you get them in there, they have the stabilizing brackets with them, and they're a little harder to get in if you have a lot of other keys on the board. So put those in by themselves first. As you can see here, we added some new rubber feet back to this case to make it look all fresh and shiny as much as possible. I'm going to do a little bit of soldering here. I'm going to try to do all of it at once, which should be not too bad to do. What we have to do here is I'm going to add a couple of headers to the Gotek. There's some headers here, 6 headers here. I don't think I need all of them, but I'm just going to put 2 rows of 3 here in order to drive, I think the rotary encoder comes off of this guy. Back here, I need to put two headers back here in order to set it into programming mode. I could jumper it with just a simple wire, but you know what? I'd much rather do something a little simpler to do this. And it just makes life easier. I've tried it before where I just like put a little piece of a paper clip in between it. And the number of times it would interrupt the programming of the firmware, I just don't want to bother with it. So what we're just going to do is we're going to, actually, you know what, before we put those in there, we're just going to desolder these holes right here. All right. We're going to clear out these holes on the PCB. Got that one. All right, come on. This is pretty thick braid. My guess is if I prime it with a little bit of solder, it'll go up like gangbusters. Or not. Let's do that. No. You know, I am going to get some thinner braid. There we go. Yeah, that did it. Very helpful to have loads and loads and loads of that. I really need to get some more blue tack to attach these pins. Actually, what we're going to do here is I'm going to put these pins in like this and then put a jumper on it. Now, it's not going to be perfect, but it'll at least hold them relative to each other and a good, keep them somewhat relative to each other. There we go. Simple. And I'll just put a little bit of tape on it. I can always just solder in one pin and adjust. Of course, I did that off camera. Let's take a look. Looking pretty good. Looks good. Now we just need to jumper, or actually create header pins for this part here, where we'll jumper this in order to set it up for programming. These don't have to be perfect, and I may even remove them after I program the firmware, but I just want to make sure I have a secure connection. I just had to sneeze. All right, there we go. I have to say, I love this pine sol. It has been a fantastic soldering iron. Not selling it, not shilling for it, just saying I like it. There we go. Done. Soldering for the Gotek is done. And really, that's the maximum soldering you can really ever need to do on a Gotek, to be frank. Nice and simple. Headers here. You could get away with no soldering on a Gotek if you simply just bridge that connection, like I said, with like a paper clip, a sprung paper clip or something like that. You don't need these unless you're doing a rotary encoder. And yeah, there we go. Done. Next part is the PSU. And the first things first, we're going to take or disconnect the PSU, the PCB, PSU PCB, from the mounting bracket. Because we're going to use the mounting bracket and get rid of this. There's just 4 screws in general connecting this to the mounting bracket. And then, you know what? I am going to swap out soldering iron tips. One second. I want this guy. It has a little more thermal mass, easier to remove some big stuff, big chunky stuff. Because what we're going to do is we're going to take a look at these nice lovely solder points down here where this guy comes onto the board. The mains it attaches to the board, or connects to the board rather, and go from there. Just making sure I got the right ones. Yes. Okay. We'll start with the neutral line here. I believe this is neutral. It's the white one. Yeah, that's the right one. Let's do this since I have a little bit of solder to it. We're just going to heat it up. I'm not going to... There we go. Got a little bit of solder on me. That cooled off quickly enough. And then we'll go for the next one. And that'll disconnect it from the mounting bracket. There we go. We have this lovely little guy working. Set aside. And the next thing we need to do is we need to remove these guys, the connector to the board. I'd like to recycle this and use this because it's very helpful to have this. I have built some of these kinds of connectors before, but if I already have them, why not use them, right? There we go. There we go. 3. Ouch. There we go. And we have reclaimed everything that we need. Next steps. Heat them up. There we go. There we go. And then we'll tin up the 12. Actually, I need to strip the 12 volt. Be right back. We will get these guys ready to go. And I'll have some heat shrink also to make sure I can close off over the terminal as well. Maybe that's another reason why it doesn't make a whole lot of sense to record this part. There we go. We're just going to get a little bit of heat shrink going. I really love this little cupping tool. Really helps the heat shrink. Looking good. Yes, I could crimp it, but I'd actually rather just solder it to the There we go. And we have the motherboard power connector done. Now, for the live and neutral, these came out of a power cord, European style power cord, or New Zealand, I think it's New Zealand actually, that somehow got sent to me, but hey, we'll use it. What I'm going to need to do, though, is I'm going to need to disconnect these guys and solder them to there. I'll clean these guys up and get them ready to go. I have extended the neutral and live, and we now need to solder on the lovely terminal guys. Terminal thingies, let's call them thingies. Oh, I need to make sure we have, yes, heat shrink to go over the ends, which is good. It's actually a really good thing. This guy is looking good. Perfect. making sure the camera is focused on the right place. There we go. All right, now we just need to heat shrink everything and hook it up. All right, here we go. Okay, now where's my big screwdriver? It's around here. Oh, there it is, right here. Boom. So this is live, and actually, if we look down here, let me get this a little better view of what's going on down here. There we are. Live neutral. All right, live connected, time for neutral. Everyone seems to say, put their disclaimers out there that if, working with mains voltage can be dangerous. Absolutely can. Don't shock yourself, don't die. That's a bad thing. I think we're going to have this guy go over the top. And 12 volt, voltage 2 is 12 volts. All right, and that looks good. Let me find some zip ties to clean this tie through here. I think that'll be a good idea. And okay, here we are. We have the lovely computer. We know it works. Just plugging in a different VGA adapter because it goes up, and since we're not elevated off of the desk or table, whatever you want to call it, I need to have that up like that. We'll now connect in my test keyboard. We still haven't reassembled everything yet because the keycaps still have a little water in them after being cleaned. We have our new PSU. Ooh, okay. We're gonna, what do you see here? I don't know if you see this. That is wonky. We're gonna work on straightening that out. From the looks of that foot, someone got impatient in trying to yank out the PSU from a computer. We are in a much better place. I see it just slid right in there. Perfect. As you can see, we are good to go. With the Gotek, I'm probably going to have to extend this a little bit, but we're okay for the moment. All right. Ready, steady, go. And there's a lot of jail bars, but that's largely because we're on an LCD and we're using the not quite as clean ST to VGA signal. Yep, we've got Ultima loaded up. Actually, let's move the camera over here. And we'll just measure some of the voltages here. So we got ground. That is a clean 5 volts there. Take a look at the 12 volts. 12.61 is a little on the high side, but that's largely because probably there's not a, that floppy drive doesn't draw any 12 volts, so there's not much drawing on the 12 volt line. All right. Looks gorgeous. PSU done. Check. Before we can program the Gotek or reflash it, we need to understand which artery chip is on here. This is an AT chip and that it ends in a 415. So that allows me to select the correct hex file in order to flash this guy. Okay, now it's time to program the firmware on the Gotek. And we're going to use flash floppy firmware. You can just go to GitHub or search GitHub flash floppy. There's lots of great instructions out there on how to do this. It's an open source firmware for these guys. It's fantastic. I have an artery controller. Look at the photo here. I zoomed in on this little chip. There's a couple different chips that are out there. Most of them are artery now. In the past, maybe 3 years ago, there were a lot of STMs as well, in addition to the arteries. And so the flashing the firmware on those is a little bit different. Now, first thing I have to do is I have to jumper these 2 points here to be able to enable programming mode. And then you can use a USB-A to USB-A or USB-C to USB-A and connect your computer to your Gotek. Bada bing. Now we're going to go to recording the screen on how to program this guy. Now flashing the firmware here, we are using the Artery ISP programmer. First thing we're going to do is we have to unprotect the Gotek. So right now we're protected, we have to unprotect it. So go to next, oops, there we go. So enable disable protection. So we're going to disable read protection and write protection as well. Once we do this, it's just going to go through relatively quickly, boom. Now we can actually go and load the new firmware onto the Gotek. So what we're going to do is we're going to select not upload from the device. We're going to add a new the flash floppy. This is where knowing which specific version of the artery we need to get is. And as you can see, I selected the 415 version. Now we click download to device and click next. There we go. Bada bing, bada bang, and click OK. And programming is done and it'll validate it. And the Gotek is ready to use at this point in time. The last thing you need to do here is you need to copy a couple of files onto the thumb drive you're going to use with the Gotek here. You need to copy hxc.config, and then within the Atari ST area, you need to copy over
the autoboot.hfv. Once you have those two ready to go, you are golden.
Okay, we're continuing on with this upgrade improvement. We have the lovely 3D printed bracket here. So I debated going back and forth between a couple different brackets, but I really, really like this style, right? That actually has a good look and feel. I'm going to have to modify this slightly, and we'll probably end up using some hot glue to put the OLED in place. But this just looks so much cleaner. We got a place for the rotary encoder. We'll find a place to mount the piezo speaker. But everything's been tested. We have the Gotek ready to go. I've already tested it with the computer with everything attached. Yes, it's a mess of wires. We'll zip tie it once everything's in place. But one of the last things that we have to do, right? So I'm going to grab an unattached Gotek just to kind of show you what it looks like when it's installed. And we have it looking like this, right? So this is actually, well, got to get that off. All right. It'll lay in like that effectively in place, right? As it's attached. And that becomes a little difficult to connect the floppy cable. Now, I think we might be able to make that work. We might not. The thing that will not work is the power cord, the Berg connector. So what are we going to do? I have some extension wires that will just extend this floppy cable a little further. Make it easy. Connect it up. I don't want to stretch things out, push things to maybe break or whatnot. So what we're going to do is we're going to snip, snip, snip this Berg connector, extend it, let's go a little higher up. It'll make it easier to strip these wires down here since it's attached to the board. Don't want it too far up though. And I just want to keep the lines somewhat similar in length. There we go. Good to go. Boom. Now, for the next part. And through the magic of editing, our Berg connector is longer. I'll use the zip tie to tidy it. All right. Through the magic of soldering, heat shrink, glue gun, zip ties, we have the Gotek installed. It is in its housing. It's attached up nicely. We have the rotary encoder over here. We have the OLED here. We have the lovely little floppy drive noisemaker buzzer thinger here. We have the extended length power cord. We didn't have to put on an extension onto this guy because it fit just perfectly. We are good to go. Be right back to go do a little overview of the case once it's put back together. Here we are. We are booting up Ultima 4 on the Gotek. Just loading up. Take a look at the OLED on the side. And it's in sleep mode. It goes to sleep quickly, but you can see that. There we are, back to Ultima 4, the Avatar. All right, so this is the end. This Atari 1040 is working gloriously. And we're going to boot up into, of course, my favorite test. And here we are. Forgot to turn the audio on. Obviously there's some discoloration on a few of the keys here, but the computer's in fantastic shape. Physically, it's gorgeous. The case is really in fantastic shape. The motherboard is fully functional. It's very clean. Didn't have any real distress or bugs in it in this case. So, first one down. A few more to go. Thank you very much for watching. I hope you enjoyed this simple fix of this lovely Atari 1040 ST.